Hi physics students, welcome back. We are about to head into part 2 of the videos for this week, and this one is the CARS lab. I'm going to start by introducing what we're going to do, and then I will pause the video and get you in some data areas, so I'll be moving the camera around the classroom for you. So first thing, we're going to be looking at motion of two different types of cars. The first car on the front side of the lab is going to be a battery-powered car. When you turn it on, it will move at kind of the same speed the entire time because the battery is powering it. The second type of car is one of the pullback cars. Those are the ones that when you pull it back and let it click, you then put it down at the start line and it will zoom forward and it will accelerate as it's moving. Okay, so we're going to end up seeing two different types of graph for the two different types of cars with two different types of motion, constant speed and acceleration. Okay, up at the top, if you look at your CARS lab, the very top part of it, the things that you need to know that we've talked about a couple of times already, you need to know that triangle, delta, means there's a change in. Time is measured in seconds, distance is measured in meters, speed and velocity, how fast an object's moving. We use them interchangeably. Technically, to have velocity, you have to be moving in a direction. We're always moving in a direction when we are moving someplace. So we just use them interchangeably. Sometimes I say speed instead of velocity, and I don't really mean to. Meters per second are how both of them are measured. And finally, acceleration is measured in meters per second squared. When using either your iPad or your phone as a stopwatch, because you'll be watching the video on one of them and using the other to time it, you have to open up the clock for your iPad and then click over to stopwatch. You'll hit start, and then as it crosses different lines, you're going to hit the button lap. That will hold it but keep the clock running. So it'll keep shoving him down to the bottom, so you'll have to go down to the bottom is where you start. At time 0, it will have 0, and then after it passes the first marking, it'll say lap 1. It will give you a time under the split column and then under the total column. If you look at lap 2, the split column is telling you how much time it took to get from here to here. We don't want that information. We want a running total of the different times. So you do have to use this far column where it says total. It will keep adding them together for you. So like at lap 1, if it took 1.54, lap 2 there, lap 3 there, and so forth. All right, we are going to get started. I have 2 tracks set up in my classroom, so I'm going to bring the camera with me, and we are going to start on the front side of the lab. We are going to run a 4-meter track, a battery-powered car, and you are going to take times at every meter mark. So at 1 meter, 2 meter, 3 meters, and 4 meters. Okay, here I am. I'm at my racetrack. I have a starting line down here on one end, and each time you see one of those tape things, when you see the front wheels go past it, you're going to hit lap on your stopwatch in order to get yourself the next time. I am going to be following along with it so that you can see it a little bit better, and I'll kind of say mark, and that will tell you when to do it. So I'm going to turn it on, put it at the starting line, and then I will say on your mark, get set, go. All right, so here we go. On your mark, get set, go. Mark 1 meter, 2 meters, 3 meters, 4 meters. Okay, we're going to get our last set of data. This one is going to be a little bit harder for you it goes a little bit faster, so you got to be ready to hit lap, 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 lap. I'm going to start it off to the right side, and then I'm going to let it go. I put meter sticks there just so you could see that a little bit better. So you are going to hit lap every time it passes one of those right there, one of those meter sticks. This time, because they can't go quite as far before the pullback cars, it will only be a 2-meter track, so we're taking data every 1/2 of a meter, so every 0.5. So I've got it marked at a starting place, and then 0.5, 1, 1.5, and 2. All right, here we go. I'm going to bring it back here. right, once you have all of the data and you start to make your graphs, you're gonna be making two different graphs. One on the front side for the car that was moving at a constant speed, and the other on the back side for the pullback car that was accelerating. Make sure you put a label on all the axes, the distance in meters over time in seconds. Make sure you get those labeled before you turn it in, check it over. The other thing to note is the data doesn't always work perfectly. But what my hope is that of the two graphs, you're gonna see two different types of lines. You're gonna see one line that is pretty straight, that would hopefully be the battery powered car, the one that moves at a constant speed. And then you're going to see one that kind of has more of a curve in the line, and that's showing that it's changing speed, or it's accelerating, it's speeding up as it goes. So once again, it doesn't always work perfectly, but that is just my hope, is that you are able to see something a little bit like that. The trickiest part is number 9. We've done it before. You just have to make sure when you're working with on the back side, you're going to make a graph for number 7. You're then going to calculate the area for number 8, and for 9, you're going to find the unit that that area is measured in. Just make sure that you actually multiply the units. Things can cancel out, and then you'll be left with what you're looking for. You are welcome to text me questions, Schoology message me, hop into Zoom at any point, and you can ask me the questions then too. So hopefully you enjoyed it. I'm sorry you weren't able to physically touch the cars, but that is what we were doing in class this week, was playing with cars, collecting data, and making some motion graphs. Thank you.